Answer to homework 7, question 8. And so the question provides us some properties of the Poisson process. So we have that the probability of n of t1, t2 is equal to k, which is equal to e to the negative lambda t times lambda t to the power of k over k factorial. And this is an equation we used towards the beginning of the semester. So the second property is if t1, t2, and t3, t4, so those are two intervals, are non-overlapping, then the random variables n, t1, t2, and n, t3, t4 are independent. And the next property is that at t, there's only one Poisson point. And then the last property is that this creates a stochastic process, which is x of t is equal to n of n between 0 and t. And so the first part of this question asks us to find the expectation of x of t, which is essentially to find the mean. And so we have the Poisson distribution back from chapter 5, I think. So you have the probability of x is equal to t is equal to e to the negative lambda times lambda to the power of k over k factorial. And so we can rewrite that as the Taylor expansion for the e to the lambda is equal to the sum of lambda to the power of k over k factorial for k equals 0 to infinity. And so when we differentiate that, we end up with e to the lambda is equal to the sum of k times lambda to the power of k minus 1 over k factorial for k equal to 0 to infinity. And so we can rewrite that as 1 over lambda times the rest of the expression here. And then we can rewrite that again as lambda equals e to the negative lambda times the sum of k times lambda to the power of k over k factorial. And that's going to give us the expectation of x. But we want the expectation of x of t. And so that property that we were given, the stochastic process, we have x of t is equal to n times 0 t, between 0 and t. And so one property that we're given in the textbook is that the expectation of n is equal to lambda times t naught. So that means that the expectation of x of t will just be equal to lambda times t. And so that's part A. So then for part B, we're asked to find the correlation from T1 to T2. So based on the properties and the definition of the Poisson process, which is an independent process, that means that our T1, T2 is equal to the expectation of xt1 times xt2. And then so for T2 is greater than T1, we can rewrite that as, well, what we do is we kind of manipulate it. So we have so we have the same thing, e of x of t1 times x of t2, then we do minus xt1 plus xt1, so that's kind of like adding 0. But we do that so that we can expand that, and we rewrite that as e of xt1 times xt2 minus xt1, and then you separate that, plus e xt1 squared. And so then from part A, we have that e of x of t is equal to lambda t, so we can sub that in to each of these pieces. And so we end up with lambda t1 times lambda t2 minus lambda t1 plus 1 plus lambda t1 times lambda t1, and that's going to give us lambda times t1 plus lambda t1 times t2. And that's the answer for part 2.